we're gonna discuss about biomolecules present in our two famous dish from the country of Greece. But first, let me introduce myself. My name is Arine by Tuvida, a student nutritionist. We're gonna tackle the ingredients, functions, and their respective structures. But before that, let me first give you an overview of what is a biomolecule. So in biomolecules, there are four main categories. The first one is the carbohydrates. Carbohydrates, they are the sugars, starch, fibers found in grains, fruits, vegetables, and milk products. And the second one is the lipids. Lipids designate fats, oil, cholesterol, steroids, and waxes in a living organism. And the third one is the proteins. Protein supplies amino acid and maintenance of the cell in our body. And the fourth one is the nucleic acid. Nucleic acid is responsible for the genetic material templates of protein synthesis. And that's it. Since I already gave you an overview of what is biomolecules, we can now find some biomolecules in our first dish, which is the creamy, soft, and absolutely delicious a traditional tiramisu latte. It is a pinkish or deep made from a mixture of fish roe and oil, and therefore high in both protein and unsaturated fat. On the plus side, it has traces of vitamin B12, which is essential for the formation of blood cells and a healthy nervous system. For its ingredients, it involves 100 grams of white tamara or fish roe, 300 grams of white stale bread, 170 to 180 ml of olive oil, 2 lemon juice, and 1 medium grated red onions. Based on its ingredients, we can easily identify what biomolecules present in our first dish. There is a presence of carbohydrate from white stale bread. It is considered to be carbohydrate because bread is usually contain a refined wheat, which is relatively high in carbohydrate. The same with the lemon juice and the onion. It is also considered to be carbohydrate because they are fruit sugar or they belong to fructose, which is a simple kinetic monosaccharides found in many plants. As well as there are also presence of lipids from the olive oil. It is considered to be a lipid because it contains fat, oil, and cholesterol. And lastly, there are also the presence of proteins from the white tamara or the fish roe. It is considered to be a protein because fish is extremely high in proteins and contains a large amount of vitamins and minerals. And that's it. Since we're done with the first dish, let's now proceed to the second dish, which is the delicious feta mimeli. Feta mimeli is another Greek food dish that can be tasted as dessert. Feta is a brine-cured white cheese made in Greece from a sheep milk or from a mixture of sheep and goat milk, and it's wrapped in a phyllo pastry before oven baked, and honey is drizzled over it. The optimum balance between salty feta and sweet honey creates a mesmerizing taste. For its ingredients, it includes 4 blocks of feta cheese, approximately 350 grams or 12 ounces, 4 sheets of phyllo pastry, 2 tablespoons of sesame seed, 4 tablespoons of honey, 1 tablespoon of red wine vinegar, 1 tablespoon of water, and an olive oil for frying. So, based on its ingredients, there is a presence of carbohydrates from phyllo pastry and sweet honey, as well as there is a presence of lipids from an olive oil and feta cheese, and lastly, proteins from a sesame seeds. The function of carbohydrates in our body are energy production, energy storage, building macromolecules, sparing protein, and lipid metabolism. Carbohydrates are critical to support life's most basic function, the production of energy. Without energy, none of the other life processes are performed. Although our bodies can synthesize glucose, it comes at the cost of protein destruction. As with all the nutrients, carbohydrates are to be consumed in moderation, as having too much or too little in the diet may lead to health problems. However, the function of lipids in our body are storing energy, regulating and signaling, insulating and protecting, aiding digestion, and increased bioavailability. The excess energy from the food we eat is digested and incorporated into the fatty tissue. The primary function of lipid is an energy reserve. It contains more than the double amount of energy than a gram of carbohydrate. Body fat is critical to our survival and good health. In a large quantities, it can be a deterrent to maintain a good health. While the function of proteins in our body are growth and maintenance, causes biochemical reaction, act as a messenger, provides structure, maintains proper pH, balance fluid, improve immune health, transport and store nutrients, and provides energy. Protein has many roles in our body. It helps repair and build our body tissues, allow metabolic reactions to take place and coordinate bodily functions. They keep our immune system strong, transport and store nutrients, and can act as an energy source if needed collectively. These functions make protein one of the most important nutrients of our body. Carbohydrates are molecules that are composed of carbon, hydrogen, and oxygen. They have a general formula of C. They can be grouped depending on the number of their monomer units called saccharide. Carbohydrates can be divided into three major groups: monosaccharide, disaccharide, and polysaccharide. Monosaccharides are the simplest form of carbohydrates. They contain either 5 or 6 carbon atoms. They have an open chain in cyclic form. A typical example of monosaccharide is glucose, which formula is C6H12O6, one of the products of photosynthesis in plants. Disaccharides are two monosaccharides bonded to each other. The monosaccharides are linked through an ether COC group. A common example of a disaccharide is a sweetener, sucrose, or table sugar. Sucrose is formed by glucose and fructose. Polysaccharides are long chain of monosaccharides units. They are called complex carbohydrate, similar to disaccharide. The monosaccharide in a polysaccharide are linked through an ether bond. An example of polysaccharide is starch, which is used to store energy in plants. It is comprised solely of glucose subunits. Lipids are large non-polar biomolecules. They are mainly composed of carbon, hydrogen, and oxygen. Unlike proteins and carbohydrates, lipids are not polymer with repeating monomer subunits. They have kinds including triglycerides, waxes, and steroids. Triglycerides are lipids composed of glycerol and fatty acid. Glycerol is a molecule with 3 carbons, each containing a hydroxyl or the OH group, while fatty acid is a long chain of carboxylic acid. Proteins are biomolecules composed of amino acid units. Amino acids are organic molecules that have a central carbon atom bonded to 4 different groups: an amino acid or the NH2, an acidic carboxyl group, the COOH, a hydrogen atom, and a variable side chain, which is R. The side chain can range from a single hydrogen atom to complex ring structure. In a protein, the amino acids are linked via a peptide bond. This peptide bond is formed between an amino group of one amino acid and an acid carboxyl group of another amino acid. A chain of 2 or more amino acids linked together by peptide bond is called a peptide. And that's it, people. Through this short video, we are now knowledgeable to identify and classify what biomolecules present not only in our 2 previous dish but in all food in general. And I hope that I deliver all the facts and information effectively and meet your expectation. Again, my name is Arin May Tuvida, a student nutritionist. Thank you and God bless.